Dear students, greetings. Welcome to this lecture. In this lecture, we are going to discuss about IPv6 protocol. Okay. So previous lecture we have discussed about IPv6 addressing. In this lecture, how IPv6 protocol is working, what is the packet format of IPv6, that we are going to discuss in this lecture. So this is week 9, lecture 3, classroom discussion topic 27. IPv6 protocol, this topic under unit 3. Okay. So after completion of this lecture, student will be able to use IPv6 protocol for mail communication. Okay. So you know how the IPv6 packets are there, how it is compressed the packets, and how the packet will be transmitted from source to destination. So because IP protocol is used in network layer, the network layer is responsible for source to destination delivery. So how the packets are transmitted from source to destination using IPv6 protocol, that we are going to discuss in this lecture. Okay. So IPv6 protocol. So some changes required from IPv4. Okay. So because IPv4 have only 32-bit address, there is depletion concept may be there, but overcoming that, we are coming with IPv6. So according to the IPv6 size, we need to change in the protocol and as well as the packet. So that we are going to discuss in this lecture. So what are the changes implemented in the IPv6? That is also we have to discuss. First one, support for resource allocation. Okay. So in IPv6, there is a type of services field has been removed. In IPv4 packet, there is a type of services are there. So instead of that field, here there is a two field is added. One is traffic field and flow label. So before going to discuss this topic, you must be know what is the packet header, IPv4 header, how it is there. So if you know that, then only we will discuss about it. Okay. So see here, this is the IPv4 packet format. Okay, so totally 32-bit length, 0 to 32 is there. Okay, so here first one version, the version will represent the which is IPv4 or IPv6. Header length, this is specifies the length of the IPv4 header. Okay, so this length will take 4 bits again. These 4 bits will represent that header length. TOS, this only you just remember, type of services, which type of service it is providing. Okay, that it will say. Then remaining 16 bits will be represent the total length of the packet. Okay, including header and data, how many length it is there, that will be represented by the total length. Then identifier. Okay, so identifier, how it is using, that identification is used for as a counter. So which is the datagram, every time it will be increased by 1. Okay, so here first packet once it sends, then it will incremented by 1. Each datagram it will be incremented by 1 by 1. Okay, so the identification is used to record the count of the number of IP datagrams are passed. And next one is flag. The flag is 3-bit. Out of 3-bit, rightmost 2-bit only we are using. In that, 1 indicates that last fragment and 0 indicates that non-last fragment. Okay, so the fragmentation it will show. The middle bit is fragmentation flag. The value 1 indicates that datagram cannot be fragmented, and the value 0 is indicates that datagram can be fragmented. Okay, so these 3 bit represent like that. In fragment offset, it is specifies the location of the fragment in a packet, and TTL, that is time to live, that specifies the lifespan of the datagram. That means how much time it will be transmitted, how much time the packet will be valid, that we are saying in the time to live. In protocol, it is showing that type of the protocol carried by the datagram, and header checksum is there. Here I am saying that this is the time to live, how much time it will take, that will consider. This is the protocol, it's a type of protocol, header checksum. So this source IP address mention the IP address of the source, destination IP address is represent the destination of the root, and then options will represent that variable length, and finally data will be there in the header. Okay, this is the IPv4 header length. That now we are going to discuss about IPv6. Okay. So what are the changes happened in the IPv6? Now you see that type of services is there in the IPv4. Instead of that, that will be removed, and instead of that, in IPv6 we have traffic class and flow label is there. Okay, so these are added in the packet. So that packet to enable the source to request special handling of the packet. The mechanism can be used to support traffic. Okay, so the flow control, it will check the flow control of video and audio, real-time video and audio transmission. And security point of view, support for more security. IPv6 is providing the more security because the encryption and authentication options are there in the IPv6. It's provide the confidentiality and integrity of the packet. So next one is the better header format. The header format we seen for IPv4. Now we will going to see the IPv6. So in IPv6, there is a header is there. The header will be have two portion. One is for header side, another one is for data payload. Okay. So this payload, no router will see the data. Okay. So only it will process the header. That's why it is good format in IPv6. There is no problem for routers. And one more new option is there in the IPv6. These new options to allow for additional functionalities. Okay. So allowance for extension. It will allow extension also. If protocol wants to extend some another packets, it will extend. For that also it's have the options. So now see that packet format. Okay. So this is the entire packet format. This entire packet format, this is the data size. Payload means data. The maximum data is 65,535 bytes. So these 40 bytes are fixed for base header, the header file. Each and every payload, there is a header is there. That header have 40 bytes. It is fixed. There is no changes. This will be changes according to the data size of the transmission. So the base header 40 bytes we are told here. This 40 byte how it will be allocated. You see the first one is version. Okay, so this version it will take 4-bit long. The same like IPv4. This will be represent IPv4 or IPv6. Second one is traffic class. Okay, this traffic class is used to do the flow control. Okay, so that means there is in IPv4 we seen that type of services. No, instead of that traffic classes will be there. So these traffic class and flow label are used to transmit the packet with proper flow. Okay, so this 20-bit will be represented for provide the special handling for the particular flow of data. Okay, so now payload length. So here it will payload length will represent only, it will take 2 bytes up to 16 bits. These 2 bytes will represent the only size or length of the data. So because 40 bytes it will be allocated fixed for base header, remaining are payload. So here the payload length will be mentioned. And next header, this is 8-field header. It's defining the type of the first extension header or type of the data that follows the base header in the datagram that will be represented. And hop limit. Hop means node limit, that intermediate nodes, how many nodes are there, that will be fixed here. If this many times or this many hops is there, then only the packet will be transmitted through that route. And we know that IPv6 address have 128 bits. This is the source address, this is the destination address. The source address and destination address will be processed by all the routers. Okay. Then payload, we know that payload is compared with IPv6, different format and meaning is there. So in IPv6, combinations of 0 and more extension headers followed by the data from the other protocols are there. So UDP data, TCP data, or any other protocol data may be there. It is not touching the data. Okay, the routers only process the base header. That is the advantage of IPv6. Okay. So in case many extension headers are required by the situation, each extension header have two mandatory field, next header and the length, that will be added with that. There is the allowance of next header is there. That is also one of the option for IPv6. So this is the next header. So this next header is providing the next extension header. So in that next header information length should be there. So then there is any next header is there, that will be shown like that. So many headers will be there, but in the payload itself. So finally the data will be there. So this some next header codes. What is the next header? If the code is like this, 00 means have to have option, 02 means ICMPv6 option, 06 means TCP, 17 means UDP, like that. These options will be represented there. The concept of flow and priority in IPv6. Okay, so IP protocol was designed, originally it is designed for connectionless protocol. Okay, so but what happened? So tendency to use the IP protocols for connection oriented. So how it is used? So example, multi-protocol label switching is there. This technology is allows to encapsulate the IPv4 packets. Okay, so but here what will be happen in IPv6? The IPv4 multi-protocol label switching will do that operations for connection oriented using in the internet protocol. So here IPv6, the flow label will be there. Okay, so directly added to the format of IPv6 datagram. What it will do? It will allow us to use IPv6 as a connection oriented protocol. So flow label means it will be the table, like routing table we are here, no, same like that flow label. Which is the source, which is the destination, which is the next pointer, which is the next router. So all the information will be there. Okay. So to a router, flow is a sequence of packets that shares the same characteristics. What are the characteristics? Traveling the same path, using the same resources, and having the same kind of security and so on. So this will be in the packet. So what is the flow label have? This flow label is considered the table. This table have entry for each activity flow label. Okay. So which is the source, which is the destination, and each router will update that the details also. Okay, corresponding flow label also it will forward. When the router receives a packet, it consults its flow label table to find the corresponding entry for the flow label value defined in the packet. So once this is the route, this intermediator is there. Once the packet comes to this router will check the flow label which is available in the table. Accordingly, it will work. It is not touching the data. It is only checking the flow label. Accordingly, it will forward it. Okay. So this once it is read the flow table, accordingly it will provide the services mentioned in the entry. Okay. So you have to remember that flow label itself does not provide any information for the entries of the flow label table. Okay. Flow label not giving any information, but the information will be stored in the flow table that will be used to transmit the packet from router to another router. So that's why we are using hop by hop options. Okay. So we can simply say that flow label can be used for speed up of the processing of the packet by the router. How? So in IPv4, what happened? It will read the entire data packet, which is have the data also. In IPv6, there is a two portion. One is the header, another one is the data. Okay, so this data part it is not checking. Only it will check the header part. Okay, so it will take very less time and pass the informations. So the same concept it will be used for transmit the data. So the flow label may be used to have to transmit the next half information. According to the information, the packet will be transmitted. Okay, so it may be used in the real-time audio video concepts. While we are transmitting or receiving the information of real-time audio and video, it may be useful. Why? Because it is no need to check the data, directly it will check the header. Okay. So fragmentation and reassembly. What is the fragmentation? Fragmentation means what I said. We have to split the entire data into some small size of segments or fragments. So it will be reassembled in the receiver side. But in IPv4, what happened? Each and every router, it will check the fragmentation and it will reassemble. Then it will send it to others. But in the IPv6, it is not required. Why? Because data will be attached extra. No need to touch the data, but header only will be accessed by the router. Okay. So here what will be happen? Source will be fragmented and destination, once receive the destination will check the data. It is received correct or not. So in between nodes, don't touch it. Okay. Only source and destination will do that. The next one, extension header. Already we seen that. So for extension header, why we are used in case if the extension header is need for some extra information. Okay. So length of the base header is fixed at 40 bytes. So if you want the IP datagram want to provide more information, means that a 6 extension header will be there. Okay. So 6 extension header will be there. It will allow up to 6 extension header. It may be 1 or 2 or 3, whatever it may be, already we seen in the diagram. So it may be up to 6 extension header. Many of these headers are optional in IPv4. 6 types of extension headers have been identified or defined in the IPv6. What are the extension headers? One is for hop to hop option. Second one is source routing and fragmentation, authentication, encrypted security payload, and destination option. So these 6 type of extension header is there in the IPv6. What is hop by hop option? Hop by hop option means it is used for when the source needs to pass the information to all the routers visited by the datagram. If, for example, router must be informed about certain management, debugging, and control functions. Okay. So if the length of the datagram is more than that particular size, we know that what is the maximum size of the data? 65 by 35 bytes. Okay, if router must have the information in case if more than this data the IPv6 bringing, it means it should inform to somebody. So that should be known by the router. For that purpose, half to half information will be there. There is a 3 type of options are there: pad 1, pad n, and jumbo payload. What are the options? First one, this pad 1 means that the option is 1 byte long, and it is designed for alignment purpose. Okay, here 1 byte it will take. That 1 byte is used for alignment purpose. That is pad 1. Pad n means it will take same concept, but it will take uh, 2 or more bytes to represent the alignment. That is pad n. The jumbo payload means it is not adding any alignment or any bytes, but what it will do that recall that the length of the payload. Okay, so recall the length of the payload in the IP datagram. What is the maximum value? 65, 535 bytes. If any extra is there or longer than payload is there, means the jumbo payload is used to define this longer length. Okay, so jumbo payload is used to define the longer length of the data, as well as it's recall the length of the payload also. The destination options, we know that there is a destination address is there. That address only that defragment it. That is reassemble the data which is sent by the source. In between routers, it's not using it. Source routing also, source address is there. The header combines the concept of strict source route and loose source route options are there in the IPv4. So this is the reflections part. You have time. So you just answer this question. What is the use of jumbo payload? You just remind that jumbo payload is used for what purpose? Your time is over. So I hope what are the options are there. So these are the options. At least you check these options. So here I hope you answered for this question, like recall the size of the payload and to define this longer length if it is required. These two are the answer. If anybody answered with the wrong answer, you just go back and read the watch the content, then you will answer it, then you will proceed further. Otherwise, if you are answered correct, then we will proceed further. Fragmentation. Again, we know that fragmentation. What is fragmentation? Fragmentation means splitting the data. Okay, that's all. So simply both IPv6 and IPv4 both are same. Okay, there is no difference. But in the IPv4, what happened? Source or router required to fragment if the size of the datagram is larger than the maximum data unit, then the network over which the datagram travels. So example, this is a network is there. If we are using IPv4, what will be happen? So it may be some smaller length cable or smaller capacity cable. This is the maximum capacity cable. So this protocol will resize it or fragment the data according to the medium used here. Okay. So the protocol will do it. But in IPv6, the original source can fragment. Okay. So source must use the path maximum transfer unit discovery technique. Find the smallest maximum transfer unit supported by the other network. So what it will do? Source will identify the entire path. According to the path, which is the minimum maximum transfer unit length is there. No, I am saying here. This is the minimum, this is the maximum, it is there. So according to the minimum, it will do the fragmentation. But in IPv6, source only do the fragmentation. Okay, so now authentication. So authentication is used for dual purpose. One is validate the message sender and ensure the integrity of the table. So both it will provide by the authentication and encrypted security payload ESP. It is for extension that provides the confidentiality and guards against the eavesdropping. Okay, so these are the things used in the IPv6. So now comparison of option between the IPv4 and IPv6. So what are the options are there? This is the comparison. No operation and end of options in IPv4 are replaced by here pad 1, pad n option in the IPv6. Okay. So the record route option is not implemented in IPv6 because it was not used. Okay, so but it is used in the IPv4. The timestamp option is not implemented because it was not used in the IPv6, but it is used in the IPv4. The source route option is called the source route extension header in IPv6. In IPv4, they are using source route option, but in IPv6, we are using that source route extension header. Okay. So the fragmentation field already we discussed the base header section of IPv4, but it is removed and it will added in the fragmentation extension header in the IPv6. So authentication extension header is new in the IPv6. It is not available in the IPv4. Okay. The encrypted security payload extension header is new in the IPv6. The encryption option also not there in the IPv6 v4. Okay. So now we are going to do the summary. Changes in the implementation. What are the changes we did? The packet wise, security wise, authentication wise, size wise, routing wise. So these are the changes we see. IPv6 packet format we see 40 bytes is the base header. That the remaining 6 by 535 bytes are used for payload. And concept of flow control we have discussed. Fragmentation and reassembly. It is only done by the source and destination, not a routers. Hop by hop options. So there is a pad 1, pad n options are there for alignment purpose. And the extension header also is for extend the payload of the other protocols also. So the summary also over. So now having completed this discussion of IPv6 protocol, now students should be able to use IPv6 protocol for email communication. So now you know how the IP packet is working, what are the information is there, how we can use IPv6 for transmit in the email communication. So these questions you just answer it. What is the use of flow label table in the IPv6? The flow label table is used for routing table. Each router We'll check it according to the options, it will work. Mention the payload size of IPv6 protocol. What is the payload size? So initially we seen that 65 by 35. The third question also is there. You just read, you will work it out. If you have doubt, we will discuss in the next class. So further doubt, you just watch, you just read from the textbook. The textbook is Data Communication Networking 5th edition. It is available in the chapter 22.2 IPv6 protocol. Further, you can check the weekly tutorial sheet. For that also, you will get idea. Thank you very much. And I hope you are enjoyed this video. Thank you very much. We will see in the next lecture.